Dear students, I am Tata Rao MSc Physics, having an experience of 20 years in teaching mathematics and physics concepts to the several students. And due to the clear explanation point of view, I got an award of International Best Teacher in the 2011. Now today, I am giving one similar triangles class with the sponsorship of the Tutors Pride. And now for initially I will take one concept that is going to call a geographical concept, which is so-called similar triangles. Similar triangles. Here, similar triangles, first of all, the meaning means, what is the meaning of similarity? The geometrical figures which are having same shape but are not necessary to have the same size, that are going to be considered as similar figures. Suppose I will give one example. You can see two triangles I am giving here. Here two triangles. One triangle is ABC and the triangle is DEF. Here the AB 9 centimeters in length, AC 9 centimeters in length, BC 9 centimeters in length, and similarly we are having the D 5 centimeters length, and here 5 centimeters length, here 5 centimeters length, and angle A 60 degrees, and angle B 60 degrees, and angle C 60 degrees, and here angle D 60 degrees, angle E 60 degrees, and angle F 60 degrees. Here what is the concept of the what you call similarity means, both the triangles having the three sides, the three sides of the first ABC triangle are equal, the three sides of the triangle DEF are equal, 9 centimeters, 5 centimeters. In the meantime, the angles, the sum of the angles in all the three triangles is 60, 60, 60, 180 degrees, 60, 60, 60, 180 degrees. So here these both are similar, and I cannot call this one as congruent. I can't call this one as a congruent. The reason is, congruent in the sense means two triangles, the sides of the two triangles must be similar, the angles of the two triangles must be similar, then only we can call congruent. Here generally one example I will take. If the two boys I am taking, the two boys having the two legs, two hands, two eyes, one nose and two ears, everything is similar. Maybe the color will be changed, the height will be changed and everything else. But because of the having the legs equally, hands equally, ears equally, nose equally, eyes equally, point of view, we will say both are similar. And meaning that the concept congruent means twins we will take. Twins, the for example, suppose the twins, we can't identify who is Ram, who is Lakshman. We can see the movies Stunt Masters, Ram, Lakshman, both are having the same features, ears and everything are same, and we can't even find out one single difference between those two people. So that is we can say, and that time the two brothers of Ram, Lakshman we can consider as congruent. Why? Reason is both are having all the features are completely equal, and but in the similarity not necessary to be size, not necessary to be equal. They are having the similar features but not similar shapes but not sizes. This is the concept of what is the similarity triangles. So now, what kind of parameters, what is the meaning of parameters means, I want to say that one, what kind of steps, what kind of some rules and regulations we are having to measure similar triangles. First of all, I will take that one, angle, similarity. Angle, similarity. In this case, I am taking two triangles. Here two triangles. ABC and DEF. In this, angle A, angle B, angle C, angle B, angle E, angle C, and you try to concentrate here. Angle D is a corresponding angle of angle A, and that is the reason I kept here one single angle remark. And here see, here angle B, I kept the angle B is the corresponding angle of angle E. That is a double remark, double marks I put over here. And comes to the point of the angle C is equals to angle F, and a triple remark I kept over here. So in this case, now what is the meaning of the angle similarity means? The angles of the here angle A equal to angle D, the angle B equal to angle E, the angle C equal to angle F. In the meantime, these triangles having sides. The sides are going to have the same ratio. If there are similarity in the angle system, in the angle point of view they are similar, but size point of view they will maintain the same ratio. What does that means? AB is the corresponding side of AB, this is the corresponding side of DE, which is equal to the BC is the corresponding side of EF, and AC is the corresponding side of DF. So in this concept we are saying, if in the two triangles the corresponding angles are equal and the corresponding sides are having same ratio, corresponding angles are equal and corresponding sides have same ratio, AB by DE, DE, BC by EF, AC by DF. So this is the first parameter what we are going to discuss. Comes to the point of the second parameter. SAS similarity. In this case, again I am taking two triangles, A, B and C, and D, E, F. Here the angle A, angle D I am marking. I am not marking other two things. Reason is, in this similarity parameter, what I am going to explain is the one angle of the ABC triangle, this one, is equal to one angle of DEF triangle. So angle A equal to angle D. In the meantime, the corresponding sides of these two triangles are maintaining the same ratio. That is, the meaning is AB by DE equal to AC by DF. So here side, angle, side. That means side. First we are considering side is having same ratio. Second we are taking angles. These two angles are of the both the triangles also equal. And the third side AC is equals to DF. And this is the second parameter. And comes to the point of the parameter number 3. In this parameter number 3, you can see two triangles A, B, C and D, E, F. In this case, the side AB is the corresponding side of DE and the side BC, this one, is the corresponding side for the EF and the side AC is the corresponding side for the DF. In this case, whenever the sides are maintaining the same ratio, similarly the angles are going to be maintaining equality. Angle A equal to angle D, angle B equal to angle E, angle C equal to angle F. The angle maintenance also there. So we have to, in this concept, we have to first, initially we have to concentrate the ratio of the two different triangles. So now these two, finally we can consider the triangle A, B, C is similar to the triangle D, E, F. So, and this is the third parameter. And now, the similar triangles chapter mainly depends upon the very important theorem, that is basic proportionality theorem. Basic proportionality theorem. In this case, I am giving one clear picture here. One triangle ABC. In this theorem, what is the main concept means? One line in the triangle is parallel to one side. See, this is the one line DE. DE, the one line DE is parallel to one side of the triangle only. One side of the triangle, that is the BC. The DE line parallel to BC. And is asking to say that one, the line DE is parallel to one side. In the meantime, this line DE is intersecting AB at the point D, AC at the point E. And when it is intersecting the two other lines AB and AC at two distinct points, then the two sides are in the same ratio. That means in this theorem, what is given means, is given one triangle ABC, is already given the line which is parallel to one side and intersecting the other two sides at two distinct points. And finally, we should prove that one, that what we call RTP, required to prove. What is the proof have? That means AD by DB equal to AE by EC. When we proved this kind of ratio, then only we can consider this DE line is parallel to BC. Until this ratio will be, we will successfully get this ratio whenever this line is parallel to BC. If this line is, DE line is not parallel to BC, this ratio is not possible. And now I will start that to prove this one. You can see now, to prove something else, we have to show some sort of the special evidences. What is the evidence that you are going to consider this basic proportionality theorem proves this ratio? And what are the constructions you can see now? Now you join B to E, you join C to D, and you draw one EF, and you draw 1 DG. Here, these are the steps, these are the constructions we must undergo to show that this theorem is perfectly giving the ratio of AD by DB, AE by EC. Now, after this one, in this triangle, what we are dealing means, we are taking the 4 triangles in this case. 4 triangles. First of all, I am comparing two triangles. First 2 triangles and the 2 triangles. What are the two? Initially, what are the 2 triangles I am going to compare means ADE. That means ADE, the triangle ADE. Is in this triangle ADE, the base of this triangle is AD. Base is AD. Don't think that one in the ADE the triangle is DE. The triangle is AD. You are comparing, and the EF is the height. EF is the height. And which triangle we have taken now? ADE. In this triangle, EF, this one, EF is the height. So now another triangle, the triangle BDE. In this triangle BDE, this is the triangle we are considering. The triangle BDE, base is BD. The base is BD, and the height is EF. Height is EF, and don't confuse here. In the triangle height EF is there, but in this BD triangle height EF is not there. How can you consider this EF triangle? That is the main concept you have to understand. And what is said initially in the concept, what is said means EF is perpendicular to AB. EF, the line EF is perpendicular to AB. Perpendicular to total full line AB, not full side AB, not just AD. If it is the perpendicular to AD, then EF is height only for the first triangle. But this EF is perpendicular to total AB, and hence EF is the line EF is also the height for the triangle BDE. Now, after this conclusion, we can see that one area of the triangle ADE in this half into base into height. In this case, half and base already we discussed. AD is a base and height is EF. EF is a height. And I am going to calculate another one. Area of the BDE triangle, half into base into height, and here half into base is DB. Base is nothing but DB, and height is nothing but EF. I already told you EF is not only a height for the AD but also DB. Reason is EF is perpendicular to AB line, AB side, not just AD. So now, when I am taking the ratio of these two triangles, that means area of the triangle ADE by area of the triangle BDE is equals to half into AD into EF by half into dB into EF, and here half of we are going to get cancel and EF, and left over thing is AD by dB. You consider this is equation 1, and now we are taking another two triangles. I told you already total 4 triangles in this. First triangle is ADE, which is the base is AD, height is EF. Another triangle is BDE, base is DB, height is EF. EF is the height for both the triangles. Reason is EF is a perpendicular line to the AB. So now we will go for that one another time. And the triangle ADE. Don't confuse the triangle ADE means the same triangle I am taking, but this time the AD triangle is not having the base AD. This time the AD triangle is having the base AE. In the triangle ADE, the base is AE. AE is the base, and the height is DG, and the height is DG. This is the DG is the height for the triangle ADE. Here the first ratio we have the same triangle ADE. That occasion base is AD, height is EF. And now once again I am taking the AD triangle. This occasion base is AE and the height is DG. Height is DG. And another triangle in this case in the side CDE. This triangle CDE. The triangle CDE. The base is EC. The base is EC. This one. This is the base, and the height is DG. The height is DG. And again that one, how come this is possible? DG is height for only AD triangle means the DG again. DG is the perpendicular line to the AC side. DG is a perpendicular line for total AC side, not just AE. So DG is a common height for both the triangles. Which two triangles? AD triangle and CD triangle. DG is a common height. So now we are taking that one. We are going to calculate the area of this one. Area of the triangle ADE is equals to half into base into height, and here half into what is the base in this case? I told you already. AE is the base. AE is the base, and height is DG. DG is the height. And next thing is area of the triangle CDE. CD is equals to half into base into height. In this case, half into base is EC. Base is EC. This is the AC, the base EC, and the height is DG. And again, now I am taking the ratio of these pair of triangles is that means area of triangle ADE by area of the triangle CDE equal to 1 by AE and DG, and same time half into EC into DG. In this case, half of and DG is going to cancel, and final ratio is AE is equal to EC. And this is the equation 2. And finally, what is the RTP we can already considered? RTP is nothing but, you have to prove that one, AD by DB is equals to AE by EC. In this case, now first we got one ratio AD by DB, second we got one more ratio AE by EC, and I want to say this ratio is proved. I can't say simply. Here one good reason is there. What is the good reason means? Here the triangle, what is the important reason? I cannot simply consider the equation 1 equal to equation 2. We shouldn't agree. Reason is the triangle BDE, the triangle BDE and the triangle CDE, the triangle BDE and this triangle BDE, this triangle, and CDE, this triangle, both the triangles CDE and BDE are having same base. Both the triangles are constructed on the same base DE, same base DE. That means, see here, BDE, this triangle is, base of this triangle is DE, and CDE, base of this triangle is DE. And in the meantime, both the triangles are constructed between two parallels. Here. What are the parallels? DE and BC. So here, these two triangles, how I am equal means, the triangle BDE and the triangle CDE both are constructed on the same base, and both the triangles are lying between the parallel DE and BC. So, and because of this kind of reason, I am going to consider AD, the first equation and second equation are equal, and finally in this case we got the ratio AD by DB equal to first one and AE by EC. So this is the basic proportionality theorem. It is also called as Thales theorem.